Sometimes, in many situations, we have scatter graphs, and our idea is to model these situations using functions. And the most common use of scatter graphs is by using linear trends. But what happens when the trend is not linear? What can we do? How could we take a scatter graph and approximate it to a function when the trend is not linear? Hi, I'm Ukofim, and in this video we're going to explore how to get the model, or how to model a quadratic function when you have a set of points. Come with me. Okay, so what's going to be the objective of today? The objective of today is to see how many conditions we need in order to approximate a set of points to a quadratic function. So if you have a linear trend, so you're just going to need 2 points. Okay, if you want to have a linear function. So in order to have our approximation using 3 points, we're going to use 3 conditions. In this case, we're not going to say points, we were going to say 3 conditions. If you have 3 conditions, then you can approximate your results using a quadratic function. But now the question is, hey, what do I need to know to have my 3 conditions and convert it into a quadratic function? So we're going to have, or I'm going to show you 3 options. Option 1, so option 1 is when you know the maximum or the minimum point, we're going to call it the vertex of the function, and 1 point. Option 2, you know, this is I'm telling you that this is 3 conditions because you have the vertex, you have the point, and you know that the vertex is the maximum or minimum point. That's why you have 3 conditions. The option 2 is when you have 3 points. Okay, so now what I want to show you is 3 examples, or 2 examples of how to use these 2 options. Okay, I'm saying 3, but it's 2. Okay, so no problem with that. So let's try to use an example here. So let's use an example that we know that the vertex is in 1, 2, and we know that the y-intercept is equals to -2. So I mean, you can set this point as 0, -2, right? So now we're going to use some way to get our quadratic function. In this case, we're going to use the form of the quadratic function that uses the vertex in the equation. So I'm going to use this form. HK will be the vertex position. So as xk is the vertex position, I just need to rewrite this as a x minus 1 to the second power plus 2. Okay, and if you want to find a, just need to set the x-intercept. Okay, so 0, -2. So when x is 0, fx is going to be -2. So a will be that will be 1 to the second power plus 2. So a will be -4. So we have our quadratic function, our modeling. The model of our quadratic function will be -4 x minus 1 squared plus 2. Okay, so that will be our first example of how to convert a quadratic function into a how to get a set of points and convert it into a quadratic function. Okay, so at this point you may ask, okay, what was the strategy that we follow to get the quadratic function if I have 2 points, the vertex and another point? It could be, I did it with the y-intercept, but it could be with any point. So think of what was the strategy followed in order to get the quadratic function if I got just 2 points, vertex and one of the intercepts. Okay, think of it. Think of that. What would be the best choice? What was the method we followed? Okay, now let's continue. So now we're going to do an example 2 using 3 points. So I'm going to use the basic points that are the intercepts of the graph. So imagine that you have these 3 intercepts. -1, 0, 3, 0, and 0, 5. Okay, so these will be the x-intercepts, and this will be the y-intercept. Okay, so now my question is, how can I get it if I'm trying to use this form, vertex form? If you try to do it with vertex form, it will be difficult because you don't know the vertex. So you can move on the other form, that is the form ax squared plus bx plus c. That is the general form, but you can modify them using the x-intercepts by using this form. Fx equals a factor of x minus one of the zeros times x minus the other zero. Okay, so if I know the real zeros, that will be a good choice to use this form. So I'm going to use this form because I know the zeros. So if I know the zeros, I don't know what is a, x minus, and the real zero is -1, so I'm going to put +1, and then x minus 3, okay, x minus 3. So what I'm doing here is just using the real zeros, because I know that when x is -1 and when x is 3, I'm going to get this function equals to 0. So now I'm going to simplify the expression, this expression. So I will get x squared minus 3x plus x minus 3. So I can simplify more. I'm going to get ax squared minus 3 plus 1 will be -2 minus 2ax minus 3a. Okay, and now I'm going to use the information of the y-intercept. So as the y-intercept is 0, 5, I know that in this form, this number c represents the y-intercept. So this member here, -3a, should be the y-intercept, that in this case is 5. Okay, so if it's the y-intercept, so a will be equal to -5/3. So I'm just going to replace a by 5/3. Okay, so I'm gonna get fx equals -5/3 of x squared plus 2 times 5 will be 10/3 of x and I know that the final term will be plus 5. Okay, I'm just wanting to verify. Real 0 is 3, 5, negative 1 is the 5 will be the y-intercept, so I'm just checking that I got this answer. Okay, so if you do the graph of this function, you will see that it's going to cross by the intercepts you wanted and by the y-intercept you want. Okay, so obviously maybe you can tell, like, okay, Hugo, but what happened when this doesn't work? You know, you're telling me something that is when you have the intercept, when you have the vertex. What happened when you don't have when you have other 3 points and you want to approximate the quadratic function, or you have many points, a scattered graph? So the idea could be kind of similar. The only difference is that you will have to solve a system of equations. Could be 2 equations, it could be 3 equations. So you need to be good at solving equations. It's out of the purpose of this video, okay? But yes, you're completely right. If you have 3 points or more, you got to solve a system of equations, okay? Quadratic trends are good because they're doing a very good approximation of your results, and you don't need to use polynomial functions like using Lagrange polynomials or something like that. So this is a good point for you to ask yourself if, or to ask, what is the strategy follow to find the quadratic function when you have just 3 points? Okay, what is the strategy to follow? What will be the strategy you will follow? Just tell me in the comments what will be the strategy for both options. Okay? So far, what you have learned, what is the line of best fit. So I hope that you know right now what is the line of best fit. You can write it in the comments. Now you know why when we have the vertex, we just need 2 points when we have the vertex. You can deduce it from this video. And you know how to determine the quadratic function when we have 3 points, in this case intercepts. Okay, just for you to continue your learning, why don't you tell me, comment on your comment there down comment, just write me in your comments, you know, just write me in your comments what will be the quadratic function that crosses by these points, negative 5, 0, 2, 0, and 0, 3. What will be the quadratic function that crosses these 2 points? Okay, what will be the quadratic functions that crosses these 2 points? Just tell me in the comments. If you could do the exercise, remember to subscribe to my tube, remember to comment anything you wanted to know. Remember to tell me if you want to learn more. You can see, if you don't know a lot of quadratic functions, you can see in my tube an explanation of quadratic functions. I have 2 videos about quadratic functions that could be important for you to understand what we're doing here. Okay? And remember, see you know how to follow me. You can see here how to follow me. See you in the next video. Bye bye.